Okay, so yesterday we started talking about graphing, and another important concept that we'll talk about in this section is that of a function. And so a function is, and I'll abbreviate it FCN, function is more or less a rule. And it's a rule that assigns to each element in D a unique element in Y. D we call the domain. F of X is the value, and then R we sometimes refer to as the range, which is the set of the Y values for which the function is defined. Y is called the dependent variable, and X is called the independent variable. Now, I want to give you a couple of examples of functions. And if I can move over here.
Yeah.
If you see the notation f of x, you know that is a function. And here are some examples. F of x equals 1 over x plus 2. And in this particular example, x cannot be negative 2 because, as most of you probably know, you cannot divide by 0. So this would actually be the domain for this function. The range for this function you would want to write in terms of y, because y represents the range, x represents the domain. So y, or f of x, which is another name for y, y cannot be 0, and that is the range. And there are two ways to think about that. You can look and see that this function has a numerator of 1, so you know that there's no way the fraction can be 0. Or you can graph it and determine that the range cannot be 0 by looking at the graph. Here is another example of a function. Now we know this function to be a polynomial, and because it doesn't have any kind of numerator or denominator, it's not written as a fraction, we would say that the domain of this function is all real numbers, because there's no problem that can occur here. There's no denominator that would cause a 0 in the denominator, and there's no numerator where you're going to look to see and make sure that you have a constant. So the range is also all reals for this particular function. And the final example that I want to show you is this one. Now we've already talked about one problem that you can expect to see, and that is when you have a 0 in the denominator. But this one doesn't have a denominator. But as we're graphing, we know that we can never have a negative underneath the square root. That would be an imaginary solution. So when we're graphing, we can't have that. So we need to make sure that we eliminate any values of x that would make this have a negative underneath the square root. So I need 5 minus x to be greater than or equal to 0. If 5 minus x is greater than or equal to 0, then we don't have to worry about there being a negative underneath the square root. So if I simply take the x to the other side, then this would be the domain of this function. Now, as far as the range goes, you notice that it's the positive square root. So it's going to be everything that's above the x-axis. So y, or your h of x, has to be greater than or equal to 0. Now we'll look later on at the graphs of these, and sometimes it's easier to tell the range with a graph. But for now, we're just going to look at the function itself and determine those two things. Now, I just want to talk just briefly about graphs a little bit more, and that'll be it for this video. Okay, and what I want to talk about is graphs increasing and decreasing, and I also want to talk about symmetry, and I want to talk about zeros or roots. And all of these you can think of in terms of functions as well. And I want to do this just with a graph itself. Okay? So if I have a graph that looks like this, let's say. Okay. And let's say this is the point maybe -1, and let's say this is the point +1, and let's say this crosses the x-axis at 2, and this crosses the x-axis at -2. And this is the point 0, 0. It's the origin. We can talk about increasing and decreasing intervals for this particular graph. This graph is increasing until we get here. And then it's decreasing until we get here. And then it's increasing again the rest of the way. So the way we would write that is we would say that it's increasing from -infinity up to -1. It is also increasing, and sometimes we use a little union symbol between those two intervals. It's also increasing from 1 to infinity. It's decreasing from -1 all the way to 1. Now notice that we only use the x-coordinates when we indicate our intervals for increasing and decreasing. I don't say it's increasing from -infinity to -1, 1, or whatever that point happens to be. We only use the x-coordinates. Okay? Now, as far as symmetry goes, this is what we would call symmetry about the origin. It's symmetry about the origin because we could fold this graph along the y-axis, and we could fold this graph along the x-axis, and it would match up. So we say that this has symmetry with respect to the origin. We will talk about 3 kinds of symmetry. We won't do them all now. But we'll talk about origin symmetry, y-axis symmetry, and x-axis symmetry as we go along with some of these other functions. Zeros and roots. This graph has a 0 here because that's where it crosses the x-axis. It has a 0 here, it also crosses there, and it has a 0 here. Now there are several names that we can use for this. We can call them zeros, we can call them roots, we can also call them x-intercepts for where they cross the x-axis, and sometimes they're just called solutions to the equation. So if we had this written as a function, we would say that it had 3 solutions. Those are where they cross the x-axis. Okay. Now, we also, because it's symmetric with respect to the origin, it has a special name. Symmetry with respect to the origin is called an odd function. So when you have symmetry with respect to the origin, it's called odd. I always remember it because origin starts with O and odd starts with O. So that's the way to remember that origin symmetry is an odd function. If you have y-axis symmetry, if you have y-axis symmetry, that is even. And it's going to look something like this, like your classic parabola, okay? That would be symmetric about the y-axis, and it would be called an even function. Because if you were folded along the y-axis, it would match up. And this particular one would only have 1, 0 right there at the origin. So we'll talk more about this in class on Wednesday. So that's where I kind of wanted to leave it on in this particular lesson, and I will also be sending out some problems for you to work for tomorrow. All right, you guys have a wonderful night. So long.